Hello everyone, we are going to study polynomials today, and let's first discuss what we are going to study. Let's take 30 seconds to say that we are going to study the zero of a polynomial, we are going to study the graphs of some special polynomials, and then we shall study the division of polynomials, how we do the divisions for polynomials, then the remainder theorem, its proof and application, then the factor theorem and its proof and applications, and we shall do various other problems which are related to the chapter of polynomials and all this division algorithm, remainder theorem and factor theorem. So let's begin. So what is the zero of a polynomial? We have discussed while talking about the types of polynomial that there is also a zero polynomial. So don't get confused with the zero of a polynomial and the zero of a polynomial. Okay, the zero of a polynomial means the roots of a polynomial, and by definition it means that if px is your polynomial, so instead of x, if you put a real number or any number k and you get the value of px to be 0, then that k is called the zero of the polynomial px. Okay, so to say it again in a different word, if we find a value for a polynomial, for example if you take just twice x minus half, and in place of x we put that value, say in this case if we put half in case of x, then 2 into half minus 1 is equal to 0. That is, the polynomial becomes 0 when we put the value half. Hence this half is the zero of the polynomial twice x minus 1. If we name this polynomial twice x minus 1 as p of x, then we shall call that half is the zero of the polynomial px. Okay, so that's the definition of a zero of a polynomial. And what does it represent graphically? So graphically, the point, we need to find that point at which the curve of the polynomial, that is, we need to draw the polynomial on the graph. And how to draw it, and how, that is very easy. You have already drawn line diagram or histogram or bar graphs. Similar to that only we can draw for polynomials also. And the point at which this curve of the polynomial cuts the x-axis, that is the horizontal axis. In the graph paper we have the horizontal axis and the vertical axis. We represent the horizontal axis with as x-axis, that you are going to study in your next chapter, coordinate geometry. Okay, however, if this is the graph, and then this point will be the zero of the polynomial. Okay, this point of intersection of the graph and the x-axis is called the zero of the polynomial. Now let us see some one-liner concept which tells you how strong you are with the concept of polynomial. So look at this polynomial, the first one, that is a zero polynomial. A zero polynomial is nothing but the zero. The number 0 is called the zero polynomial. And what is the degree of this zero polynomial? We have already discussed in previous video, but however the degree of this polynomial is undefined. Okay, for the 0 is also a constant, so don't get confused with constant polynomial here, because a constant polynomial, okay, has the degree to be 0. For example, the constant polynomial 5 can be written as 5 into x to the power 0. Hence the degree of x is, the highest power of x is 0, and hence we say that the degree of the constant polynomial is 0. However, we can also write x or 0 as in this form. So that means 0 into 1, right? So why can't we define? Now those discussions are a matter of different video, we have to discuss that broadly. However, that is not defined you need to remember currently. Okay, so what do you have till now? That the degree of the zero polynomial is undefined. Then the degree of the constant polynomial is 0. The degree of the linear polynomial is 1. Then quadratic polynomial 2, cubic polynomial 3. Now we need to look at the zeros of these polynomials. For example, zero polynomial I have already told you, that is just 0. Constant polynomials are infinite. 1, 2, 3, 4, minus 3, 2 by 2, or 2 by 4, pi, anything can be constant polynomial. Okay, those all the numbers that you know can be your constant polynomial. For example, 5 is your constant polynomial, and we don't write this x to the power 0 for constant polynomial, right? Hence, that x to the power 0 gives us the constant polynomial degree as 0, right? We get the degree of the constant polynomial as 0. But what is the number of 0 that we can get for a constant polynomial? That is 0, because there is no point at which this polynomial 5 is going to cut the x-axis. If you have an x-axis like that, and then this vertical line represents your polynomial, say this point is your 5 for the polynomial. Okay, so when x is 0, then the polynomial is 5. When x is 1, the polynomial is again 5. So when x is 2, then also the polynomial is 5. So as you can see, it will form a parallel line, and parallel line will never intersect, right? So this is the constant polynomial 5 in the graph, and it will never intersect the x-axis because it is parallel to the x-axis. Hence the number of zeros is 0 for constant polynomial. I am repeating, don't get confused with the zeros here and the zero polynomial. Okay, this 0 is a number, and this zeros is the root of the polynomial, the value for which the polynomial becomes 0, the value of x for which the polynomial becomes 0. Okay, or you can say the curve of the polynomial intersects the x-axis. Alright, so what is next? The linear polynomial. The linear polynomial, I have given one example here, twice x minus 1. The form of linear polynomial we have discussed earlier, it is ax plus b. So if this is our polynomial and we equate it to 0, then we shall always have x is equal to minus b by a. That is our value of x for which this polynomial will be equal to 0. Hence the root of the polynomial, linear polynomial, is always minus b by a when the form is given ax plus b. Okay, so what is the root of twice x minus 1? It will be 1 by 2. Why 1 by 2? Because it is minus b, right? So we have to give minus b. B is minus 1. So this minus and minus makes it plus. Ultimately we get 1 by 2. Now the linear polynomial always intersects the x-axis. It will always intersect the x-axis. Now remember, this constant polynomial was what? It was a parallel line. The constant polynomial was a parallel line. For example, I gave the constant polynomial 5. For example, if we take the constant polynomial 2, then we shall have the constant polynomial like this along the line 2. Okay, but this is the line for twice x minus 1. Okay, this line intersects the x-axis. At which point? At this point. This point is what? Can you guess what is this point? This point is half, that is 0.5, 0.5. Okay, as you can see, it is between 0 and 1, exactly between that, so it is 0.5. So what is the maximum number of zeros that a linear polynomial can have? the maximum number of zeros that a linear polynomial can have is 1. It will maximum number of polynomial zeros, maximum number of zeros is always equal to the degree of the polynomial. Okay, remember that the maximum number of zeros is always equal to the degree of the polynomial. The degree of the polynomial is 1, hence the maximum number of zeros will be 1. What is the minimum number of zeros for linear polynomial? That is also 1. The linear polynomial always intersects the x-axis. Alright, so next let's look into the quadratic polynomial. Now I have given examples of 3 quadratic polynomial because all the 3 are a bit different in case of graph. For example, the first one, quadratic, that is second degree, so the maximum number of zeros that it will have is 2. What is the minimum number? 0. So that means it can also have 1 0. It can have 0 zeros, it can have 1 zeros, or it can have 2 zeros. Okay, now this 0 that I am saying means what? 0 0 means what? The first 0 means the number 0, the second 0 means the root of the polynomial. Okay, so for the first one, 4x plus 1, this is a polynomial for 4x plus 1. Do you see this polynomial intersecting this x-axis? This is your x-axis. Does it intersect? No, it doesn't intersect. It is 4x square plus 1. As you can see, it is 1 unit above it, above the 0, right? So if you put the value of x in this equation as 0, then what do we get? 4. Oh, can you see it? Sorry for the mishap. Anyway, this is 4x square plus 1. So if you put 0 in place of x, what do we get? We get 0 square plus 1. So 4 into 0 is 0 plus 1, and that is equal to 1. So when x is equal to 0, as you can see here, the value of px is 1, right? Hence this graph is 1 unit above it. Anyway, let's look into the next one. Do we have any zeros in this polynomial anyway? Do you see here any zeros? No point of intersection with the x-axis, so no zeros. Let's look into the next polynomial. What do we have? We have 4x square minus 4x plus 1. 4x square minus 4x plus 1, if you break it down, then it is of the form of twice x minus 1 whole square. That is a minus b whole square form. So whenever you have this a minus b whole square form for a polynomial, quadratic polynomial, you can see that the number of zeros will be 1. That is, it will just touch the x-axis, as you can see at this point, 0.5. Okay, at 0.5 this polynomial is just touching it. Now why 0.5? As I say, what is the quadratic polynomial? It is twice x whole square. So if you equate it to 0, that would mean that twice x minus 1 equal to 0, and that would mean that x is equal to 1 by 2, which is 0.5. Hence this 0.5, as you can see in the graph. Okay, next polynomial for again quadratic, and this time it will have 3 roots, not 3, 2. Maximum for quadratic is 2, right? So look at here, this is the polynomial for polynomial graph. Okay, 5x square minus 6x plus 1, the graph is here. So at which point do we see intersection? 0.2 and 0.1. So this equation, if you do the middle term factorization, then what would that become? It would become 5x minus 1 and x minus 1. So on factorization, we get this. So if we equate this px equal to 0, then we have x equal to 1 by 5 and x equal to 1. This will give us 1 by 5 and this will give us 1, right? Hence 1 by 5 means what? 0.2. That is our 0.2, and 1 we have it here, right? So hence you can see that a quadratic polynomial can have 0 roots also, it can also have 1 root, or it can also have 2 roots. When 1 root? When it just touches it. And all those things you are also going to get in class 10. To try to remember it nicely, you are going to get the same chapter in class 10 where these graphs will be studied. Now let us look into the cubic polynomials. So I have given you some examples of cubic polynomial. What do we have here? We have that the number of zeros will be from 1 to 3. I have not given 0, notice here. I have started from 1 and then from up to 3, that is 1, 2 and 3. Cubic polynomial can have zeros, how many? 1 zeros at least, 2 zeros or 3 zeros. Now remember, we are studying only about the real roots, okay, or the real zeros. That is, our answer will be real numbers. Hence all the graphs that you are going to see are real numbers. For cubic, things are more complex, but those are things to study later. Now look at the polynomial that we have given here. What is it? It is x cube plus 8. So since it is plus 8 and we don't have any other factor here, as you can see, when it is plus 8, so when x is 0, the point of intersection of this vertical line with the graph is at 8. Notice these things, these are useful. In future it will help you. Anyway, in how many points do you see the intersection of the graph with the x-axis? What is important for us? With the x-axis, only 1 point, that is -2. Now check what happens if we put -2 in place of x. -2 whole cube plus 8. What is -2 whole cube? -8 plus 8, hence that is equal to 0. That means this point is the 0 of the polynomial, okay? And vice versa, if the graph cuts the x-axis at a point, that point is the 0, okay? And if for a point the value of the polynomial of, if for a point means if for a value of x the value of the polynomial becomes 0, then that point will be the point of intersection of the graph of the polynomial with the x-axis, okay? Now in this graph you see here cubic polynomial, do you see the pattern of the graph? For quadratic it was cup, right? Either it is cup shape or inverted cup. For cubic you have up and down and again up, right? So in how many points do you see this curve in touching the or intersecting the x-axis? At this point, right? And at this point 1. So when x is equal to 1, the value of px should be 0. Now see, this is 1, so what is px? 0, right? When x is 12, what is px? This one. Or 12 not, it is 1.2. So x is px is this value, right? This value out here. And how do we get this value? Put a parallel line and this point gives us the value of px. So this is 0.2, so it should be 0.4, right? Would you like to calculate for 1.2? Try to calculate by putting 1.2 in this polynomial for x. Wherever you see x, put 1.2, then cube it here, you square it here, and you put 1.2 here and multiply and do the simplification and try to find the value of x. Okay, and it should be 0.4 according to the graph. Just check it and verify yourself sometime. Okay, so how many points do we see the curve 4x cubed minus 8x squared plus 5x minus 1 intersecting the x-axis? Only 2, right? So how many zeros do we have? 2. Here we have 1 0, here we have 2 zeros, and for the next one where it is x cubed minus 5x square plus 8, you have 3 zeros. This point A, point B and point C. It is intersecting the x-axis at 3 points, and here also you can notice that here what is the constant? It is 8. So at 8 the curve is intersecting the px, the vertical line, right? Enough with the graphs, and let us just move into the next part where we shall find. Okay, before that we need to note something. What is it? A zero of a polynomial need not be 0. Don't get confused. Okay, the zero of a polynomial can be any number. Just now we have seen that it could be half, it could be a different, like 1, it could be 0 also. For example, if this is the x-axis and this is your px and a linear line passes through this point, then this is also, then 0 is the 0 of the polynomial. Okay, so hence we have written here 0 may be the 0 of a polynomial. For example, if the polynomial is, say this is x, this polynomial is x, so here this x polynomial passes through the point 0, hence we can say that 0 is a 0 of the polynomial x. Now let us see how do we find the value of the polynomial at a given value for x. What do we have here? We have x is equal to 1 and we need to find the value of this polynomial. So at the first point we do is we write the polynomial and give it a small name as px, and then we replace wherever we see x as the value 1, because we need to find the value of px as 1. So in the next line we are going to write p of 1, because we need to find the value of the polynomial at 1. So hence in place of x here we also write p of 1. So it is p 4 into 1 cube minus 8 into 1 square plus 5 into 1 minus 1, and which is equal to 4 minus 8 plus 5 minus 1. And what is that equal to? 4 minus 8 is minus 4 plus 5 is equal to plus 1, and minus 1, that is equal to 0. And hence what can we say? Can we say that 1 is the 0 of the polynomial, right? Yes, we can say that, because p of 1 is equal to 0, hence we can say that. Similarly for 2, all you need to do is replace this 1, okay, and put the value 2. It was 2 cube, it should be 2 cube x cube, right? So this is 2 square, this is 2, and this was already 1, right? Excess we have removed, and then obviously your next line will change. So what would that be? 4 into 2 cube, 2 cube is 8, so 8 4s are 32, again 8 into 2 square, 2 square is 4, so 8 4s are 32, 5 into 2 10 minus 1, and this 2 obviously gets cancelled, you have 10 minus 1 which is equal to 9, and that means that it is not equal to 0, right? Hence we don't need to say that it is not equal to 0 in this question, because here we only need to find the value of the polynomial. Hence the value of the polynomial at x equal to 2 is 9, and 2 is not a 0, that I am telling you, because we shall use it later in this video only to solve other problems. So can you do it for half? I hope you can do it for half. It's quite easy. You just need to replace this 2 and introduce half at its place, right? So it is half whole cube. This would be again half square, 5 into half. Okay, and then you need to do the evaluation, and I hope you can do the evaluation. You will be needing to take the LCM and all those things, so you do it yourself. And let's move on to the next point. This question is exactly same as the previous one, but only the form is different. Earlier the polynomial was given to you and they were asking you to find the value of the polynomial at a particular point, right? This time they have directly given you this space, p of something we have to find. So here it is given that p of 0 we need to find. So px is already given, so p of 0 you need to just write, and 4 into 0 square plus 1 is equal to 1. That's it. Next, p of 1 you need to find, so you write p of 1 is equal to 4 into 1 square plus 1 is equal to 4 plus 1 is equal to 5. Then p of 2 also, that is quite easy, right? 4 into 2 square plus 1, and that is equal to 4 4 is 16 plus 1 equal to 17. Next equation, what do we have? You have p of y. Does not matter whether it is x or y, you just need to have the variable. So p of 0, you replace y with 0 minus 1. This is 3 into 0 minus 2, so you need to operate inside the bracket, hence it is minus 1, and this becomes 0, right? So minus 1 into minus 2, and that is equal to 2. Then p of 1 will be equal to, this would be 1 minus 1, because here we have y, so in place of y we are writing 1, so this is 3 into 1 minus 2, and this is 0, right? 1 minus 1 is 0, hence your entire answer will be 0. For p of 2 you can find it yourself. Let us move on to the next part of the video. We need to verify. Now this is a different question, only the format of the question is different and the pattern of writing is different for your answer. Otherwise the concept is totally same only. So the px is given and the value of x is given, and we need to find whether it is a 0 or not. And in the first problem only itself we have shown you that if the answer becomes 0, if we replace px, we need to find p of the value for x, right? So p of 1 by minus 3, so what would that become? 3 into 1 by minus 3 plus 1, so this 3 and 3 get cancelled, so ultimately that becomes minus 1 plus 1, so that is equal to 0, and hence therefore we can say that hence x equal to 1 by minus 3 is a 0. Of px. Okay. For the next one, you can see the problem is, you can see a number pi here. Don't get confused with that. You need to replace x with 4 by 5, so 5 and 5 will get cancelled. Your answer would be 4 minus pi. 4 minus pi is not equal to 0, hence x equal to 4 by 5 is not a root or not a 0. Any word can be used. They can use the word 0 also in your question paper, or it can be used root also in your question paper, so be careful with that. Now the division of a polynomial. Now division of a polynomial, you have to pay a little bit of more concentration, because the rules you should engrave it nicely into your brain. Okay, So the first step that you need to do, that you need to arrange the polynomials in decreasing order of their degree. Here you have two polynomials given to you. One is 4x minus 5x square plus twice x plus 2. It is already arranged in decreasing order of their degree. You have 3, 2, here you have 1 and you have 0, right? The power of x. And here you have 2 and here you have, do you have the 0 one? Yes, you can see that it can be written as x square plus 0x plus 1 into x to the power 0, because this is the constant. So this 0 1, however, we don't write, it is in decreasing order. This x to the power 1, it is 2, it is 1, and then it is x to the power 0, right? So it is in decreasing order of their powers, the variables. However, this term is missing, this middle term, because the coefficient of the middle term is 0. So we might not write that. No problem with that, and you can also write that, but however, that is useless. So first step is what? You need to arrange the terms in decreasing order of the powers of the variable. Alright, and if you have any term missing in the dividend, this is your dividend, right? If there is any term missing, for example, if you don't have this x term, then what you do is you will introduce plus 0x while writing it in decreasing order. Now this 0x matters only in case of the dividend. In case of the divisor, it is not necessary to write it. In case of dividend also it is not necessary, but only when you become a little bit of expert in doing it, then won't be necessary. And you need the clear understanding of integers. Okay, when the integers are opposite in sign, say for example plus 4 minus 5, and together when we take it, it is equal to minus 1, right? When there is, that is, we need to do the difference, and we put the sign of the bigger, numerically bigger number. And if both are same sign, say 4 and minus 5, minus 4 and minus 5, then in that case same sign, so we sum it up, 4 and 5, and we put the sign of the numerically bigger number. So be careful with that. If you know that, then this division will be simple. Otherwise, if you go with the book, put a minus sign, plus sign, it will take a lot of time. So what is the first step is done? Arranging in decreasing order of the powers of the variables. Done. Now you need to look at the first variable, first term of the divisor and first term of the dividend. What should you multiply to this first term of the divisor, x square, to get 4x cube? That is all. Okay, so what should you multiply? You should multiply 4, because here you have the constant 1, so 1 should be multiplied to 4 to get a 4, right? Hence the constant part is done. Now we need to go for the variable part. Here you have x square, so x square, if multiplied to x, it becomes x cube. So we shall write x cube here. So what are we multiplying? We are multiplying 4x. So 4x into x square gives us 4x cube. Now this part I have explained you. I hope you have already studied those things in class 8, and hence all this explanation won't be required. It will be very fast while doing it. So 4x should be multiplied to 4x square to get 4x cube. Now you have to multiply this with the remaining terms it has already been multiplied to x square. Now you need to multiply with the remaining terms. The remaining term here is only plus 1. So 4x into 1, what is that equal to? 4x into 1 is 4x. So since it is x term, hence you write it in below this x, 4x. The sign is very important. If a sign is required, then you introduce a sign also. So now you need to subtract it. You don't have any number between them, right? Hence you can directly drop them. Okay, so how do I drop it? I will write minus 5x square, this would be plus 2, and you need to just think that instead of this plus, this is opposite in sign. Whatever, if it is minus, then you have to think the opposite sign, and you need to consider this number and this number, but the sign of this should be opposite. For example, you have plus, so you need to consider, or this was plus 0, right? Or minus 0, doesn't matter. So it is 0 and minus 4. So what is 0 and minus 4? It is equal to minus 4 only. So minus 4x. Don't write this minus sign, just consider the opposite sign and take the two numbers together, okay, along with this sign. Every time you have to take it together. No subtraction, no addition, no need to think of this plus, minus and anything. Just two integers, one whatever integer you have, and the other also whatever integer you have, you will get after doing the opposite sign. Next, minus 5x square minus 4x plus 2 becomes your dividend this time. The same step you need to repeat, only thing is your dividend changes from the first one, now your new dividend, and you continue just the way you do in case of numbers. So what should we multiply to x square to make it minus 5x square? Obviously minus 5. So minus 5, if you multiply, it will become minus 5x square. We always try to match the first term, and then the rest of the things we adjust accordingly. So minus 5 now should be multiplied to 1. So minus 5 into 1 is minus 5. So we have to write it below the number, because here the variable part for minus 4x, we don't have any number here, we don't have the x part here, right? Hence that will remain blank in this case. So we have 0 here, so it will just drop down, minus 4x, and this is minus 5, so just consider the opposite. So plus 5 and plus 2 together 7, right? That's it. Now what you see is you have minus 4x plus 7. Why are we not doing it more? Because the degree of the divisor is always greater than the degree of the remainder. This is the remainder Rx, okay, and this is the divisor Gx. This is our quotient Qx, and this is our dividend Px, the first one. Hence we shall use the division algorithm, and what can we write? We can write that Px is equal to Gx into Qx, the quotient, plus remainder, okay. And if we represent this polynomial, then we can write it like this: 4x cube minus 5x square plus 2, that 0 part is not necessary, this is our px. Then we need to write the gx, which is x square plus 1, and then we need to write qx, 4x minus 5, and then the remainder is minus 4x plus 7. So that is the division algorithm for a polynomial. Okay, now we shall do another division for a different polynomial, but this time we shall lessen up the explanation and see how fast we can do it, okay, without going through broad explanation, and you will see how fast it can be done. But there is another way. Instead of doing the division, also we can find this division algorithm, and we shall discuss about that also. So we are this time dividing 5x cube minus thrice x square plus 4x minus 7 by x minus 2. Okay, we already have it arranged in descending order of the powers of the variable, hence we just multiply 5x square to x to get 5x cube, hence we get it. Then 5x square into 2 we need to do now, minus 2, so it would become minus 10x square, and since it is minus 10 I have to consider plus 10 minus 3, so plus 10 minus 3 is equal to plus 7x square. Then we have to write the remaining portion and then repeat the process. This is plus 7, I can avoid this plus sign also, and then what do I have is I have to multiply 7x to x to get 7x square. So 7x square, then 7x with minus 2, so that should be minus 14x, and hence this minus 14 will become plus 14 and plus 4, so that is equal to 18x, and minus 7 will be dropped down. So we need to multiply 18 to x to get 18x, and 18 to minus 2, which is equal to 36. So this minus 36, it will become plus 36. Now remember, we are already matching these two, hence the cancellation will be 0 only. Here also it will be 0 because this is plus here, so if you consider the positive sign, negative sign, so minus 5 and plus 5 0, minus 7 and plus 7 0, so we don't write all those things, we do it in the intention that we can remove them. Next part, what do we have? Plus 36 and minus 7, so that is equal to 29, plus 29, so that's our remainder, right? This is our Rx, this is our Gx already given, this is the Px, and this is our Qx. So division algorithm, that way also you can write it. Let's move on to the next part, which is remainder theorem. Just now you got that a remainder 29, right? So in this kind of problem, what was the divisor that we choose? The divisor was a linear polynomial. So whenever the divisor is a linear polynomial, we can find the remainder as a constant, because as I told you, the degree of the remainder should be less than the degree of the divisor, right? And what is the degree of the divisor when it is linear? It is 1. The degree of the divisor when it is linear is 1. Hence, what is less than 1? Less than 1 is 0. So the degree of the remainder should be 0. That means it should be a constant polynomial, and this 29 itself is a constant polynomial, and hence we can move to the remainder theorem and we can prove it now. But let us look into the definition of the remainder theorem. What does it say? First, Px should be a polynomial and the degree should be greater than or equal to 1. The Px was what? it was the dividend, right, in division. So px, the dividend should be of degree 1 or more than that. If it is less than 1, that is 0, it is a constant polynomial, then this is useless, because that will be just like dividing 54, that is a degree less than 1 degree, which is 0 degree, by another 0 degree, for example by 12, right? So number by number only it will become. Hence the degree should be greater than or equal to 1. Next, this a that we are going to take should be a real number, okay? And if we divide this px now by a linear polynomial x minus a, then what will be the remainder? P of a. That would mean that in this previous problem we got the remainder to be 29. So 29 should be equal to P of a. And what is a? We divided with x minus a here. And what are we dividing here? X minus 2. So that means it should be P of 2, right? Because when it is x minus a, the remainder is P of a. So when it is x minus 2, the remainder should be P of 2, right? So let's prove the remainder theorem now. So let's prove the remainder theorem. Okay, I have already written it so that it takes less time for us. So we have taken a polynomial px and it is being divided by gx, which is x minus a, and it is linear. Remember that it can be in the form of ax plus b also. Then what we would take? We would take as x minus x plus b by a. Now since it is plus, so in place of p of a, it will become p of minus b by a. Now these two a are not same. This a comes from this theorem and this a comes from this value. So instead of a, we could have used any other number also. For example, we could have written as, say, mx plus b. We can write like this. Alright, so this linear form also, the theorem can be extended. However, what are we studying now? We are studying for x minus a. So if it is x minus a, then the remainder will be p of a, and if it is x plus a, then the remainder would be p of minus a. Why? Because x plus a can be written as x minus a, right? So that means if you compare it with this value, then x is same, minus is same again, but in place of a we have minus a. So hence in the answer also, in place of p of a, it will become p of minus a. So when it is plus, it is p of minus a. Now let us see the theorem and its proof. Okay, so px is divided by the polynomial x minus a, and the quotient is qx, remainder is rx. That we can take. If we divide something, then we shall get a quotient and a remainder, right? Hence we have taken the quotient to be qx and the remainder to be rx. So now by division algorithm, what can we write? We can write that the dividend is equal to the divisor x minus a into the quotient plus the remainder, right? But what do we know? The degree of the divisor x minus a in this case is always greater than the degree of the remainder. Hence, what is the degree of the divisor? It is a linear polynomial. Hence, the degree is 1. So, in place of degree of x minus a, we write 1 is greater than the degree of rx. So, that automatically says that the degree of rx is equal to 0. So, when the degree of a polynomial is 0, that means what is it? It is a constant polynomial, right? When the degree is 0, then it is a constant polynomial, as you can see here, right? Thus we have written that Rx, the remainder, is a constant polynomial, and constant polynomials, that means it is a number, so let the number be R. We have taken it. We could have written it Rx also, that doesn't matter. So now we need to put the value of x equal to a in the polynomial. If we put x equal to a in the polynomial, then the left hand side and the right hand side should be equal, right? So what is p of a? That is the value of the polynomial at x equal to a. That is how we calculated earlier. How do we calculate the value of a polynomial at a point? By replacing the value of x with that value of that point, right? So p of a, so here x minus a was there at this place, hence we write a minus a, we replace x with a at this point, right? So a minus a is equal to qx, a minus a into qx plus r. So a minus a is equal to 0, 0 into qx is 0, so 0 plus r is equal to r. So that means what did we get? We got that pa is equal to r. That means the remainder is equal to pa. So hence when px is divided by x minus a, the remainder is p of a. Let's move to remainder, the factor theorem now. Now the factor theorem is very easy and it's totally related to the remainder theorem, and it says that if this PA that we calculated right now is 0, then that x minus a will be a factor. Obviously, if the remainder is 0, then x minus a, when we are dividing by x minus a and the remainder becomes 0, then x minus a should become a factor. That is the definition of a factor. And similarly the opposite one also, this is the converse one, that is if p of a is equal to 0, then x minus a is a factor. Similarly, if p of minus a is equal to 0, then x minus a or plus a, opposite sign, okay, plus a is a factor. Similarly, if x plus a is a factor, the first one, then p of minus a will be equal to 0. Remember this, don't get confused. I have repeated it because this is important. Students often get confused in this point and they do mistakes, so you should not do it. Hence I have repeated it even if it bores you. And the proof I have already told you only, that is enough. Whatever I have told you, that if using the remainder theorem, what do we have? That if x minus a is a factor, let me pause it and write it all. So the first part of the factor theorem, what does it say? That if x minus a is a factor of px, then p of a should be 0. That is, if p of a is 0, only then x minus a is a factor. So how do we prove it? By remainder theorem, what do we have? That if x minus a divides p of x, then p of a is the remainder, right? Now x minus a is a factor of px according to this first point, right? Oh, no, not the first point, according to the second point. This is the second proof, okay, doesn't matter, the first proof is same. If x minus a is a factor of px, so x minus a is a factor, that would mean that the remainder is 0, and hence p of a will be also equal to 0. This is the second part of the theorem. The first part would be, I'm just erasing and pausing and writing it all. So the first part now, again using remainder theorem, what do we have? We have p of a is equal to r. We just got it, right? P of a is equal to r. We got it here, p of a equal to r. that is the same thing that we are using. If P of A is equal to R, then what can we say? That P of A is 0. Why? Because it is given, right? If P of A is 0, so we can replace this P of A with R from this equation. That means the remainder is 0, and if the remainder is 0, then the divisor should be a factor of the dividend. Here I have written A again, it should be x of the dividend px, right? That is your remainder theorem. Just vice versa, if this is a factor, then your P of A will be equal to 0, and if P of A is 0, then x minus A is factor. That's it. Let's move on to the next part and find the zeros of some polynomials. To find the zeros of the polynomials, all you need to do is you need to equate the polynomial as 0. For example, you have question number 1, you have to equate twice x plus 1 is equal to 0. So you will take it lat, and that would imply x is equal to minus half. Hence the 0 of the polynomial is equal to half. That is all, the first one. Okay, that's it. So the next equation, what do we have? We have lat 4 x square minus 4x plus 1, and you probably know middle term factorization, right? So equal to 0 we need to do, because we need to find the 0 of the polynomial. So hence implies, so we can write it twice x whole square, this is in the form of a minus b whole square, so into 2 into twice x into 1 plus 1 square equal to 0. So this is twice x minus 1 whole square, and hence you have x is equal to half. This is 1 0 for this polynomial. For the next one, let me erase it. As you can see, this polynomial is cubic, so that middle term splitting and directly equating to 0 will not work. Hence you need to find at least one value or at least 1 0 of this polynomial. Only then you can factorize it or find the other zeros. So since it is cubic polynomial, it can have up to 3 factors, okay, or 3 not 3 factors, 3 roots or 3 zeros. And for that you need to use the trial and error method. And for trial and error method, what you need to do is you need to look at the constant. The constant is minus 1. So what are the factors of minus 1? The factors of minus 1 can be 1 and minus 1, right? These are the factors of minus 1, 1 into minus 1. Hence we need to try for the value of p of 1 and p of minus 1. If any one of them is equal to 0, then we can move forward and find the other zeros easily. So let's see. Now this factoring process, try to remember it, it is very important. That will shorten your work, otherwise you have to go on doing trial and error. So here the factor is the number is minus 1, so the factor of minus 1 is 1 and minus 1. Now you also have 4 here, so you could have multiplied this 4 and you can also calculate those factors also. So if it becomes minus 4, then you will have more factors. For example, you will have plus minus 1, you will have plus minus 2, and you will have plus minus 4. So total 6 possibilities are there for which the polynomial can be 0. 6 possibilities. You don't know which of these 6 will be 0. Maximum 3 can be, but for here the value can be 1 or it can be half also, and we are calculating for real roots only. Hence any one of them should be equal to 0, but we shall try with 1 and minus 1 first. So let's see what do we have in our stock for minus 1. So let us take first we shall define the polynomial. Let p of x is equal to 4x cube minus 8x square plus 5x minus 1. Therefore p of 1 is equal to 4 into 1 cube minus 8 into 1 square plus 5 into 1 minus 1. So that is equal to 4, this is equal to 8, this is plus 5 minus 1, which is equal to 4 and 5 is 9 and 8 and 1 is 9, so that is equal to 0. So since p of 1 is equal to 0, we don't need to do any more, and we can say by the factor theorem that since p of a is 0, then x minus a is a factor. So p of 1 is 0, therefore x minus 1 is a factor. Okay, factor of which one? Factor of px. And then we need to divide this polynomial 4x cube 8x square by x minus 1, but the division process is too long, hence we shall use a different process for solving it. Okay, so how do we do it? So let me write the polynomial. So here is the polynomial 4x cube minus 8x square plus 5x minus 1. We need to factorize it, and we already have a factor x minus 1. Now x minus 1 is a linear polynomial. Linear means degree 1. Okay, and here the degree is 3. Alright, so I have to do 3 minus 1 plus 1 time. Okay, so what is 3 minus 1? That is equal to 2 plus 1 time. So if we were doing the process for second degree polynomial, then we would have done it 3 minus 2 plus 1. Okay, now what is this 3 minus 1 plus 1 that I am writing here? It means 2 plus 1, which is equal to 3. We shall write 3 times the linear polynomial. Okay, leaving a little bit of gap in between them. I have written it 3 times. Why 3 times? Just now y calculation I have done it, and how to get it? The degree of this polynomial minus the degree of this polynomial, that is the divisor, plus 1. So now, like the division process a bit, you need to see what number should we multiply to make it 4x cube. So we should multiply 4x square, right, to x to make it 4x cube. So 4x cube is balanced, right? This portion is balanced. Now we need to balance 8x square. Now see, 4x square is already multiplied with x. It is not multiplied to minus 1, but it should be multiplied, right? So 4x square into minus 1 is equal to minus 4x square, but we need minus 8x square. So how many more do we need? We need more minus 4x square. So we need an minus 4x square extra. How do we match it? So here we write minus 4x, because minus 4x into x is this minus 4x square, right? So this minus 8x square is also balanced. So this two multiplication is complete. This multiplication is done. Now we need to multiply minus 4x with minus 1, that is equal to plus 4x. But how much x do we have? We have plus 5x, so we need more 1, so we write here 1. So 1 into x is 5x, so this 5x is also balanced. Now if you have done all things correctly, the last one will automatically match. 1 into minus 1 is equal to how much? Minus 1, so last one is also balanced. So this process is better than division because it also helps us in checking. In this last step, it helps us whether we have done it correctly or not, and it is also shorter. Okay, you have to just do it again. For example, 4x square, I have written y because we need to balance 4x cube. So 4x square into x is 4x square. Now 4x square should be multiplied with this minus 1 also, hence 4x square into minus 1 becomes minus 4x square, but we have minus 8x square, so to balance it we need more minus 4x square, hence we put this minus 4x here, which gets multiplied to x and becomes minus 4x square. So this minus 4x square here and this result minus 4x square here together makes minus 8x square, right? And similarly we continue to balance the others. So now what do we have? We have x minus 1, and then you have 4x square minus 4x plus 1, and we have already factorized this 4x square minus 4x plus 1, and that was equal to, we could write it in quadratic form, twice x whole square minus 2 into, you could do middle term factorization also, and you could do it this quadratic formula also, you can use it. I am using the formula here. So we can have x minus 1, and here it would be twice x minus 1 whole square. That's factorized. Okay, so we need to find the zeros, so we have to equate this polynomial to 0, hence you can just write it like this, give the implied sign, put it 0. If you don't give this implied sign and do the equality, that would be factorization, and here it will be 0, and therefore we can write x is equal to 1 because of this one, the first one, and then half for the second one. So 2 zeros we have for this x. Let's move on to the next problem. What do we have? We need to factorize this polynomial. So the same technique will be applicable out here also. How do we do it? We write the polynomial, let it be px, not px, it should be py, right? Py is equal to 2y cube plus y square minus 2y minus 1. So what is the factor that we need to take? 2 and 1 we need to multiply, right? But since it is minus 1, try for 1 and plus 1 and minus 1 at the first place. So p of 1, in your syllabus you are not going to get too complicated values. At most you are going to get plus 2, minus 2, or plus 3, minus 3 maximum. More than that you are not going to get for these values to check. So for 1, if you check it, it will be 2 into 1 cube plus 1 square minus 2 minus 1, or this into 1 I forgot, we have to do into 1 minus 1. So this is equal to 2 plus 1, this is minus 2 minus 1. It was totally evident actually by looking at the number, which is equal to this 2 and 2 gone, 1 and 1 gone, so that is equal to 0. And since p of 1 is equal to 0, we can say that x minus 1, therefore x minus 1 is a factor of px, or x minus 1 not, it should be y minus 1, because here the variable is 1. So y minus 1 is the factor of py, not px, py, right? So now we need to factorize this, and you could divide also, and you could do the way that I have shown you right now, but I prefer this one because it takes less lines. Y square minus twice y minus 1. So I have to write y minus 1 how many times? 3 times, because here it is 3 and 1. 3 minus 1 is 2, 2 plus 1 times. So y minus 1, again y minus 1. I prefer this process because it is shorter, and at last step it also gives us checking for us. So we need to multiply 2y to make it 2y cube, right? So now this 2y cube is already balanced. So 2y into minus 1, that is equal to minus 2y. We already have a minus, oh no, that is wrong, it should be 2y square. So 2y square into minus 1 is equal to minus 2y square. But how many y square do we have? We have plus y square. So what should be added to minus 2 to make it plus 1? Plus y square means plus 1, right? It should be plus 3. So 3y. So 3y square it will become. So calculate it, 3y square and minus 2y square is equal to how much? Y square. This can be done orally only. This writing is not necessary. If you are used to variables, you can do it very easily. So now 3y into minus 1. So what is this? Is also balanced. 3y into minus 1 is minus 3y. But how much do we have? We have minus 2y. That means one extra minus we have. So to balance it, we need a plus y to balance that. So plus 1. So 1 into y is plus y. Now you check it again. 3y and minus 3y and plus y. That is equal to how much? Minus 2y, right? Don't do all those things. Try to do things orally and get some used to with this algebra, and things will become very easier. And last, 1 into minus 1 is equal to minus 1. This last step is also balanced and it's checked, right? Hence the equation gets reduced to y minus 1, then twice y square plus 3y plus 1. Can we factorize this middle term for the quadratic part? Yes, we can. So we can write 2y square plus 2y plus y plus 1. If we do the middle term factorization, we shall get this, and then y minus 1, and it can be written as 2y common, right? And hence y plus 1 for the first one, and next, without thinking, just write y plus 1 again, and then try to match it with this one, last two. Then if you match it with the first one, it is plus 1. Then the last step will again give you for checking. 1 into 1 is 1. Yes, you have done it correctly. So now you can just write it y minus 1, y plus 1, and twice y plus 1. Hence it is factorized, right? So this is one factor, this is another factor, this is another factor, which are getting multiplied to each other, right? So what do we have more to discuss? We need to use the factor theorem to determine whether gx is a factor of px or not in each cases. Your gx is already given. Okay, let me zoom it. Your gx is already given. It is x plus 1. Hence you need to take p of minus 1. You need to find the value of p of minus 1. If p of minus 1, see this is plus 1, hence p of minus 1. If that is equal to 0, then it is a factor, and if it is not 0, then it is not a factor. So you just need to put the value of minus 1 here in place of x. It will become minus 1 whole cube, then in place of x square, then in place of x again you need to put it, and you need to check whether the answer is 0 or not. Similarly, in the next problem you have x minus 3, hence you have to find for what? P of 3. If P of 3 is okay, zoomed it too much. If P of 3 is equal to 0, then it is a factor. Okay. Next we need to find the value of k if x minus 1 is a factor. Let me do this problem, and that will be the end of the class. So you need to notice here that it is given that x minus 1 is a factor of this, hence p of 1 will be equal to 0. P of x is already given, and that would mean that k into 1 square minus root 2 into 1 plus 1 is equal to 0. I have just replaced the value of x as 1, and hence we get k, this is minus root 2 plus 1 is equal to 0. So if we take root 2 on the other side and 1 on the other side, then it will become plus root 2 and minus 1, right? So k is equal to root 2 minus 1. That's the value of k for this question, and we end our polynomials for this much part. We also have the algebraic identity part up to your exercise. So up to exercise 2.4 we have completed. The last is left, and we'll do it separately because that is a bit different, where you need to study the identities. Okay, thank you.